Hello everyone. In this second video, I will give you a very basic introduction to Python so that you're familiarized with it before the start of the seminar. The idea is not to give you the most comprehensive tutorial on Python, but instead to cover the fundamental aspects that will allow you to interact with the code we will use through the seminar. I will point you in the direction of other great resources in case you want to dig deeper into Python. Okay, so to start, we will have to go to the repository we used last time, and we do that by going to github.com, and then as we did last time, we should sign in into our account. I will sign in into my own account, and when you are in your account, you'll see this dashboard that we saw last time, and the way in which you access the repositories you have in your own account is just by going to this icon at the top right of the screen. You click on that, and then you see that there's an option that's your repositories. When you get here, you'll see I have a bunch of repositories, but you should have the top one should be the one we forked last time, and we'll go to this repository and we'll start our Python tutorial. Once we're here, we're gonna go to the notebooks folder. And then for today, we're going to go to the Intro to Python Jupyter notebook. As I mentioned last time, all of our notebooks will have this opening Colab button. And so we'll click that so that this Jupyter notebook opens in Google Colab and we can run all of the Python code on it. Let me start by briefly motivating the use of Python as the programming language to demonstrate and implement all of the methods that we will see throughout the seminar. So as a starting point, Python has great implementations of multiple machine learning methods. The scikit-learn library, for instance, has the implementations of logistic regression, decision trees, multiple clustering algorithms, and much more. Python, Keras, and JAX are all libraries that provide building blocks for neural networks. And Hugging Face provides high-level abstractions to work with modern language and computer vision models. If you go to their webpage, for instance, and then visit the models page, you can see that they provide a bunch of computer vision related tasks, such as image classification or object detection, and a bunch of natural language processing tasks, text classification, table question answering. It's just a lot of possibilities. We will explore some of the computer vision and natural language processing tasks through the seminar. In addition to the great implementations of machine learning method that Python has, Python is also a very versatile language in that it can be used for anything from web development to neural network estimation. And it is also a language that has lots of support, both from a large community of active users and something a bit more modern from generative language models such as ChatGPT that can create useful fragments of code for you. Let's move now to some actual Python code. We will start by speaking about variables and data types. Variables are Python objects that can store any value that you wish. They are very convenient since you can assign them a value and then you can recover that value later in your code at any point. So the way in which variables are defined is just by using the equal sign. So if we go here and we create my variable, for instance, we then use the equal sign and assign any value we wish to this variable. So let's use a number, let's give it a 2, and then we run this cell of code. We have our variable defined. If we want to recover the value that it stores, we just need to get a new cell of code and then ask Python what my variable is. You see that it is remembered in the memory, and if you run here, you'll get the value of 2, right? So we've defined a variable by using the equal sign, and then once we do that, we are able to recover its value at any point in the code. But not only we can define variables that are integers. You see this is just the number 2 without any decimals or anything. We can also define other types of variables. So there can be strings. So let's do my string. strings are defined by the quotation marks. It's at the start and at the end. We can have something like hi everyone. And the same, we run the cell, and then this value is stored in memory, and we can recover it at any point. So if I ask Python my string, it will give me hi everyone. So we can also have my float, for instance. So this would be not an integer, but a number with a decimal value, so 2.4, for instance. We can also have booleans, which are true or false. So they're just two possible values. So my boolean can be true. And you can see that Python gives it a special blue color since it recognizes that true is a special boolean. We can also interact with any data type without necessarily storing it in a variable. And each data type has a set of operations that we can use on them. Python allows you, for instance, to easily use all mathematical operations on numbers. So that means that we can do 2 plus 2 and we'll get the mathematical operation done. We can also do 2 times 4 using the asterisk, and we get that done in Python. We can do 2 divided by 2, and we get that done. And we can also do 2 to the 8, and this exponentiation is done with a double asterisk. So here we go. And we can do these operations without assigning them to a variable, but we could as well do something like my math operation. So we define a new variable again that maybe is just the result of some sort of maybe multiple mathematical operations at a time. So 2 times 2 plus 2, maybe times 8. And as I said earlier, this would be stored in this variable that we can then later on retrieve by using its name. But numbers are not the only data type to which we can apply some operations. We can as well, for instance, add strings together by using the plus sign. So if we had, for instance, hi, and then we use plus sign, everyone, maybe we add as well one blank space, and we add an exclamation sign at the end. By using the plus sign, we are concatenating these different strings together into one. So the plus sign has meaning when you apply it to strings. The division sign doesn't. So if you try to do something like hi divided by everyone, that really doesn't make much sense. So you'll get an error telling you that it's not a type of operation that is supported between string and string. So this is also something that's useful. Python errors are usually very informative of what's going on, but even if the division is not defined between two strings, the addition with the plus sign is. Lastly, you can also use mathematical operations on booleans, and they will be taken as 0 for false and 1 for true. So that means you can do something like false plus true would be equal to 1, since it would be 0 plus 0 plus 1. Let's check that. And something like true times false would be 0, since it's 0 times 1. So include the division, multiplication, addition, all of that is supported for the Boolean type as well. Now that we know the basic data types in Python and the concept of a variable, we can move on to lists. Lists are very important Python objects since they can store multiple values together. So instead of having a variable that just has a 2, we can have a list that has a 2, a 3, a 4, a 5, whatever we want. And lists are represented by square brackets. So let me show you how one can create an empty list. That's a starting point. So let's say empty list. It's the same idea of a variable, right? We define a name use the equal sign, but then we use the square brackets to put within them the elements of the list. So we'll leave this one completely empty. So Python understands that we're creating an empty list. And then when we look for empty list, we'll get actually nothing, just the square brackets. So we know we're working with an empty list. If we wanted to actually create a list with elements, we can do something very similar, but putting elements within the square brackets. So let's do maybe like an integer list, right? So square brackets, and then we separate elements using a comma. So we have 2, 3, 4, 5, 6. So square brackets again, and then comma separated elements. We run the cell, and same as the variable. Once we go to a new cell, we can query whatever the list has inside. So integer list, and here we go. It's all of these elements that we put inside of the list. But lists do not have to be numeric. One can have, for instance, a string list, and we can, again, square brackets and then strings defined by the quotation marks. So we can have something like maybe some names: John, Pedro, Juan, and again, comma separated, and Nicolas. And when we define the list, then we can go later on and see what it has inside. And lastly, list can also have mixed data types, right? So I've created two lists that are only integers here and only strings here, but I can have a mixed list which has maybe an integer, a float, a boolean, and some text. And no problem. Problem, because I used a dot instead of a comma. It's always comma separated. So there you go. I have my mixed list that has integer, float, boolean, and string. Once we create a list, we can do multiple things with it. For instance, we can retrieve particular elements of the list by using the position of the elements within that list. So we do that by putting the name of the list. So let's use the mixed list as an example. And then using square brackets and the position of the element to get it. So if we want to get the first element, for instance, we would use a 0 inside, since Python index elements starting from 0. So the first element would be 0, not 1. And once we run this, we see that we get the number 2, which was exactly the first element in our list. And if we wanted to get the second element, we will have to use the 1 here, right? And we get the float 4, which is our second element, and so on. So if we wanted to get the third element, we use the 2, and we get true. And if we wanted to get high, which is the last element, we'll use a 3. One thing that actually is very handy when getting elements from a list is that if we want to get the last element, we can also use something like -1, right? So that gives us the last element, and let's check that that's true, and we get high, so the last element of our list. Not only we can query elements in our list, but we can also change them. And we do that by using the index of the element we want to change, the position in the list, and the equal sign as before. So let's do that. Let's say we want to change the number 2, so the first element of the list. We want to change it for a 10. So we will do that by using the name of the list, using square brackets, getting the position of that element, so in this case 0, since we want to change the first element, and then assigning to that position the new number, the new value we want to put. So in this case, it's a 10. So good, this was able to run. And now let's check the whole list to see that the change has really worked. So there we go. We no longer have a 2 here. We have a 10. So that's how you would change elements in a list. Again, let's say we wanted to change the last element, so the -1. Instead of hi, we want to have hello. And if we check the list now, we'll see that it has really the change has taken place. This is our new list with those changes. We can also add new elements to lists, and this can be done through several methods, but I will show you how you can do it by just using the plus operator, the plus sign. And so for instance, let's take our mixed list, and let's say we want to add to it the number 4 and the number 6. So this is done just by using the plus sign and defining this second list that we want to add to our first list. And so when I run this operation, I see that I get a new list back that has the elements of my original list plus the elements of this new list I provided here. And we can also, for instance, save this into something we can call my new list. And it can be defined as that sum of two lists. And then when I actually look for my new list, I will get this longer list. And finally, one other type of list we could define is one that instead of having individual values in it, has more lists inside. So this would be a list of lists. And we can do this by simply creating my whatever, let's call it my list of lists, and we start the list with the square brackets, and then because we're going to have lists inside, we as well use square brackets. So let's have maybe one first list of integers, and then we separate this list from the second list with a comma. Let's have a second list of strings, A, B, C, and then let's have a third list of booleans, so true, false, true. And when we run this, we'll have our new list of lists. And this is something one can do. This resembles a matrix, for instance, but it's not the case that the list within this bigger list have to be of the same size. You can as well, for instance, have just 2 elements here, and there's no problem with that. In addition to lists, Python provides another very useful object called a dictionary. Dictionaries are represented by curly brackets, and they consist of a collection of key and values. And so to see that in practice, let's just start by defining a first dictionary. Let's call it my dictionary. And so we use the equal sign as always, and then instead of square brackets, as in the case of a list, we use curly brackets. And so we'll leave it empty for now, just to define a first dictionary that it is completely empty. You see, we get back this curly brackets with nothing inside. But the most interesting case comes when you have a dictionary that maps particular keys to their values. I will show you this in the context of grocery shopping, where we would want every item, bananas, apples, to be mapped to the quantity we need to buy. So let's try that. Let's create a dictionary called my groceries, right? And we use the equal sign and the curly brackets. So this is how we would have an empty dictionary, but we want to put things on it now. So we need to start by using the key. And in this case, a key would be the item we want to buy. So we can say we first want to have bananas. So let's say bananas. And then we use the colon. And then we give it a value. So bananas will be mapped to, let's say we need 10 bananas. We're going to do some banana bread or something. And this would be the first item of our dictionary. So it's a key, bananas, and a value 10. So we use a comma to separate different items of the dictionary, just as in the case of a list. And now we can say, we have a second key, which can be apples. And then we need just one apple, let's say. And then we maybe also want olive oil, why not? And we need one of that as well, right? So we separate with commas the different items of the dictionary, and each item is composed of a key and a value. So let's define this, and we can see that if we look for what my groceries is, it will show us exactly what we wanted to have. So bananas 10, apples 1, olive oil 1. So the magic of the dictionaries comes from the fact that when you want to access the values that are inside of it, you won't do this by referencing the position that they have within the dictionary, because elements in a dictionary, they don't have positions. They just have keys, right? So it doesn't make any sense to think about element in position 1 of a dictionary. No. What it makes sense is to think about the value associated with the key bananas, right? So it's a very different logic than a list, where in the list you were looking for elements according to position. In a dictionary, you look for elements according to their key. So let's say we forgot how many bananas we wanted. And so we go to my groceries, and then we use square brackets, and we type here the name of the key for which we want to get the value, right? And we can already see that Python suggests us with some of the available keys in the dictionary, but let me type bananas. And when I run this, I'll get 10, because that's the value that's associated with bananas. So dictionaries, again, they don't have the concept of ordering, so you cannot get elements by their positions. You would always get elements by making reference to the key that's associated with that value. So in addition to getting bananas like this, we could get the number of apples by doing my groceries and then typing the name of the key we want to get. So it's apples, and we'll get a 1 since the value associated with apples is just 1. From this example of groceries shopping that I've created to demonstrate dictionaries, it would be easy to think that keys have to be strings and values have to be numbers. But this is not the case. We could as well have let me go up here. We could as well have a dictionary where keys are integers and values are strings. So let's say we want to create a dictionary that maps numbers to their name in English, right? So we want to have the number 0 with the word 0. And so we could easily do that by creating a new dictionary called my numbers, say, and again, curly brackets, and we'll start by, so not a string, so we'll have the number 0, right? We use a colon, and then the key 0 will be associated with the word in English for 0, which is 0. And then we have 1 acting as a key, colon, and then 1. And then let's just have one more, 2 and 2. So this dictionary has integers as keys and strings as values. So let's run this, and if we take a look at my numbers, it's exactly what we would think it is. So it's 0, 0, 1, 1, 2, 2. And we can actually do the same thing we did above, accessing elements by using the key. This time the key would be just the number. So let's have a 2 here, see what happens. So we get 2, right? So key difference, this is an important difference with list. When we're using the 2 here, it doesn't mean that we are looking for the element in position 2. It is that we're looking for the value associated with the key 2. Now, in addition to accessing values of the dictionary very easily, another nice feature of dictionaries is that we can add new key value pairs very simply. So we do that by typing the name of the dictionary, And then within the square brackets, we will add the new key we want to add. So we had 0, 1, 2. So now let's go crazy. Let's have 10, and then we use the equal sign and we'll assign a new value to this key. So we'll write the English word for 10, right? So now if we look again at the dictionary, so we look at my numbers, we'll see that we have a new element. It's called 10. So it's a key, the number 10, and the value, the word for 10, right? So that's how you would add new elements. We could add, let's do one more. So we could add the number 20, let's say, equal, and we write the word for 20. And we see that my numbers has 20 over here, right? One last thing that is very easy to do with dictionaries is to get all of its keys. And we can do that by just typing my numbers, then dot, and then keys, like this. And then you see we get all of the keys that the dictionary has. And then we can do the same with values, following the same logic. So my numbers dot values. So we can see we get all of the values of the dictionary. Don't worry, I'll explain a bit later exactly what this syntax is doing over here. For now, it's just useful to know that we can query dictionaries, we can add new values to dictionaries, and then we can also see all the keys and all the values like this. Now that we have seen what lists and dictionaries are, we can start thinking about useful things to do with them. One of the most basic things we can do with them in Python is just looping over their elements. We do this by using the for loop. So let me demonstrate the syntax and use of the for loops through a concrete example. So let me start by creating a list with a very creative name. So let's call it my list, square brackets, and let's put a bunch of numbers, 1, 2, 3, 4, 5. So all of them comma separated as we saw before, and let me just print the output. Okay, so I have my list here. Now let's write the for loop that will iterate over all of these elements of the list. And so we start the for loop, of course, with the keyword for, right? You see it gets colored with this pink color, showing that it is a recognized word in Python. So for, and then we're going to define a name that will represent each one of the elements that we're going to iterate over. So traditionally we use I here, but this could be anything you want, K, J, a word element. So I'll show you later, but let's stick with I. So for I in another keyword, and then we provide the list we want to iterate over. So for I in my list, then we use the colon and start a new line. This new line is indented, as you can see. And in here, we're going to define what we're going to do with each one of these elements. In this case, I'm just going to print, I'm just going to display each one of these elements. So I do this by using this print function in Python. I'll speak more about this later, but for now, you just need to know that this would display the value of I. And so I have my for loop here. So it's for I in my list, colon, and then I define the action I'm going to do with each one of these elements. So when I run this, you'll see I get in each line each one of the elements that were contained in the list. So it just shows that we one by one iterated over all of these elements of the list. And as I said, there's nothing special with the letter I in here. So we could replace that for something like for element in my list, a colon, and then we do the same printing. And we get the same result. So we can choose any name we want for naming each one of the items that we will get by iterating over the list. But we can do actually much more than just printing. We can, for instance, sum all of the numbers of that list. So let's demonstrate that. We can do like define something like my sum, and maybe we can start that as 0, right? And then we can write a loop for, let's call it k to change, for k in my list column. And then what I want to do here is add the value of k to this global value of my sum, right? So that my sum at the end represents the sum of all of the elements in the list. And so the way I do that in Python is that I do plus equal. So this is just a short way. So let me show. So plus equal k would be equivalent to write my sum is equal to my sum, so the value that my sum had before, plus k. These are two equivalent ways of writing the same. I'll leave them both. Let's go with the more explicit one. But the idea is just to show that we could as well use this for loop to create a global sum of all of the elements of the list. So we run this, works well. And if we see the value of my sum, it's 15. So that just represents the sum of all of the elements of the list, 1 through 5. We can also iterate over the elements of other objects in Python that are not lists. So for instance, if we want to iterate over a sequence of numbers that are equally spaced between them, we can use this range function to do that. Instead of defining a list that has all of those numbers, we can do the following. We can do something like for I in, so same syntax as before, and then we use this range function. We define the starting point, so let's say from 1, and we define the endpoint not inclusive. So the 6 here would mean that the last element would be number 5. So the start is inclusive, the end is not. And so instead of, this is just a replacement for the whole list I had before. And if I do this printing, as I done before, we have exactly the same result. 1, 2, 3, 4, 5. So this is another type of Python object that's not exactly a list, and we can iterate over it. But moreover, we can also iterate over a string. So for instance, let's define something called myString, and let's say hello. And I can do for I in myString, right? Colon, and then I'll print each one of the elements of the string. In the case of a string, elements are just the characters that compose the string. So when I do this, I get each one of the letters of the characters that compose this string. We can also use a for loop to iterate over the elements of an object that is not necessarily stored as a variable. So what do I mean by that? So over here, instead of, I'll do a for loop for k in, but instead of using myString, the variable myString, I will type here the string that I want to iterate over. So hello, and then I do print k, and I should get exactly the same result I had above, right? So I did not use the predefined variable, I just define the string as I go in the loop. When we have very simple loops like this one, in which we're only doing one particular action to the element that we're iterating over, we can actually write this for loop as just one line, and we can do that by doing for k in, let's keep using hello, and then instead of going to a new indented line, we just keep writing here what we're gonna do with k. So it's gonna be just print k. And this should as well produce the same output as above. One last and a bit more advanced usage of this one-line for loops is within the context of the creation of a new list. And this is what we call a list comprehension. If it's not 100% clear, don't worry. I just explained this now because this is something I use frequently in my code. So if you see something like this, you get a sense of what's going on. And so let's demonstrate this with, let's come back to what I've called my list before, which is just a sequence of numbers from 1 to 5. And what a list comprehension does is, let's see, we're going to create a new list. So we start with the square brackets. And within that, we're going to have a for loop that modifies, let's say, the elements of my list, right? So let's say we would want to add 2 to each one of these numbers from my list. So we want to have like 1 plus 2, 2 plus 2, and we want to have this new list be stored somewhere, be created, this new list that just adds to the original elements from my list. So the way in which I do that is, so I'll start defining what I want to do with those elements. So let's say I want to do I, that will represent each one of these elements of the list, I plus 2, and then I write sort of the one-liner for loop that I was writing before. So for I in my list. And you see, it's a very simple structure, and what this for loop within this creation of the list is doing is just adding 2 to each one of the elements of my list. And so the result will be a new list. You see that adds 2 to each element of the list. Okay, so that was a very brief introduction to for loops, and now I'll move on to demonstrate another one of Python's basic functionality, which is the conditional statements. They allow us to verify if a logical condition is fulfilled and, based on that, execute certain operations that we decide. In Python, these conditional statements are initiated with the word if, and Python supports a bunch of basic logical operations such as equal, not equal, greater than, smaller than. In addition, after an if statement, we can also use elif, which is a combination of else plus if, to verify, to check for additional logical conditions. And we can also have an else to finalize the conditional statement, to capture what happens when none of the logical conditions above are fulfilled. I will show you how this combination works a bit later. Okay, so how do we write a conditional statement with if? So let's do a very simple example. So we start, as I said earlier, with the if word, that again it's specially colored, indicating that it's a recognized word by Python. So if, let's say if 2 is smaller than 1, then this is the condition, the logical condition we want to verify. So if this is true, we put a colon, and then we specify what we want to happen when this is true. And maybe let's say that we want, if 2 is smaller than 1, we want to print a message that says yes, right? And so we run this and nothing happens, of course, because 2 is not smaller than 1. But if we had said 2 is greater than 1, then we'll see that we get the message printed, right? So if this logical condition is true, so 2 is indeed greater than 1, then we get the message printed. We can also have logical operations on non-numeric data types, such as strings. So for instance, we can do if, let's say if hello is equal, right? Double equal sign, equal to, let's say, maybe a misspelled version of hello, then print they are the same, right? And so we would expect this message to not be printed, since we see that hello here is different than hello here. And indeed, that's what happens. We don't see the message. But if we write something like if hello is different, right, from hello, print they are not the same, we would expect the message to be printed as it is here. And lastly, these conditional statements can of course also operate when working with variables. So let's say we said something like A is equal to 10 and then B is equal to 20, right? And so if I write a conditional statement like if A is smaller than B, I want to print maybe a simple message like A is smaller than B, right? And I get this message printed because, as you can see, A, which is 10, is smaller than B. So this just to show that you can directly apply conditional operations on variables, not only on the numbers themselves defined here. So if we want to start building more complex conditional statements, we can use the else keyword. And else, as I said earlier, will specify what happens when none of the logical conditions above it are actually fulfilled. So what does this mean in practice? So let's keep using A and B for this example. So let's say we have the following. Let's say if A is, let's say if A is equal to B, I want to print something like they are equal, right? But what happens if they're not, right? In this particular case, nothing would happen, right? Nothing would get printed if A is not equal to B. But if we want to specify what would happen when they're not equal, we can have something like else, right? Colon again, and then we can say what's going to happen if this logical condition A equals B is not fulfilled. So let's say we're going to print something that says they are not equal. And when I run this, I will get the second message, they are not equal, since, of course, this first logical condition was not fulfilled. I can clearly replicate the same structure with a different logical operation. So I could have something like, let's say, if A is greater than B, then I print A greater than B, else, colon, and then indented line, I will print A is not greater than B, right? Same thing. So I will get the second message since A is not greater than B. Lastly, if I want to check for a sequence of logical operations in order, I can use elif for that. So let's create an example. So let's say we do something like if A is greater than B. So same as before, right? So we'll print something like A greater than B. But let's say we don't want to just have a binary case where if true something, else something else. We want to keep checking for more things. So if A is greater than B, we'll print A greater than B. But we can do elif, so else, if, let's say A is equal to V, I want to print A equal to V. And then we can finally go to an else and say, and print something like A not greater and not equal to B, right? So we'll only get to this else portion of the code if this first condition is not fulfilled and if this second condition is not fulfilled. So when we run this, we'll see that we end up in this last condition since A is actually smaller than B. Finally, I will close this video by explaining the concept of a function in Python. Functions are reusable pieces of code that perform one or multiple operations. Functions usually take inputs and return outputs, and they are defined by the use of special word and parentheses. Python has a bunch of pre-built functions ready for you to use whenever you need. Here in this link, there is a full list of the functions and their descriptions. You see functions all have this parentheses and this keyword defining them. I'll leave this for you to explore, but I also provide some of the most used pre-built functions in Python, such as print, that we have extensively used before. So we see it here, right? It just takes as an input any string that you want, and the output of this function would be just to print out these characters you provide to it as an output. There's len, that is a shorthand for length, and that would return the length of the number of items in a list or the number of characters in a string, depending on the object you give it. You have abs for the absolute value of a number, max for the maximum number in a list, min for the minimum number in a list, and range that we've used before, that takes a starting point and an end point and will give you all of the numbers in between. In addition to these pre-built Python functions, additional functions can be brought into Python by importing packages, and functions can also be defined by users by using the def and then specifying the name you want to give to the function and parentheses. I will show an example of this later. Let me now quickly demonstrate the usage of some of these pre-built functions. So let's go here and let's go back to our print function. So we started with the keyword, right? Print, and we use parentheses. And once we do this, we see that actually print gets a particular color that indicates that Python recognized print as a function, a pre-built function. And so inside the parentheses, we'll give the input that print requires, which is some sort of string, and let's just say something. And when we run the code, we get the output, right? So this is the basics of using functions. We call it by its name and use parentheses to provide any input. But we can see how other functions work. So let's use the len function for length. Again, color changes once it recognizes that we're looking for a particular function. And let's give it as an input a list. So let's create a list that has 4 elements. And when we apply the function, we get a 4 in return, which just is the count of objects within the list. If we apply the len function on a string, right, like this, it would return the number of characters of that string. If we provide no input to the function, so let's say we do something like len and then leave this blank, provide no argument to the function, then we get an error, right? Because the function needs something to calculate the length of, and so just calling this function this way is not acceptable. And we can also take a look at some of the functions that work on numbers. So remember, there was abs for absolute value, and we can calculate the absolute value of 10, right? Of minus 10, sorry, so that's 10. And we can also use some of the functions that do some operations on lists of numbers. So let's find the max, for instance, of a list that has 10, 200, 5, and 300, and we get 300. So these are just some of the pre-built functions in Python that you can just use by calling them with their name and using parentheses. But I leave you to explore the rest of them by yourself, going to the link that I left in the notebook. Another way of using functions in Python is by getting them directly from the object to which you want to apply the function. So what do I mean by that? So let's come back to the dictionaries that we defined before, and we can quickly define a simple dictionary here. So just call it my dictionary, sign, curly brackets, so something like we did before, bananas, 10, apples, 20. Now we want apples. And so remember, we get the dictionary like this. And what I want to show you now is that when we have my dictionary created and we use a dot, we can access some of the functions that can be applied to the dictionary. So what we did last time was that we wanted to get all of the keys of the dictionaries. So we did dot keys, right? And so this is exactly the same syntax of the keyword plus the parenthesis. But in this case, we are using the dot on the object to which we want to apply the function. So this is just telling us that we're going to apply this keys function that Python has already built for us to my dictionary. And what this keys function does is just listing all of the keys that are part of the dictionary, right? So we can do the same with the values function. So my dictionary.values is exactly the same thing as with keys. It's the name of the function and the parenthesis, and we get the values. And this is certainly not exclusive of dictionaries. So I'll show you that if we have, for instance, my string that is maybe hello in capital letters, right? Then I can as well use the same logic. So my string dot, and I, for instance, know that one can do lower, or can use the lower function to make all of the characters of this string lowercase. Let's see what we get. All right, same idea, the name of the function and the parenthesis, and all of this is applied to my string through the use of the dot. And if we had something like, let me show you, if my string was something that had multiple words, for instance, we could as well do something like my string dot split, and we will split the string using the white spaces that it has, right? We get a list where elements are obtained by splitting the string according to white spaces. And finally, we can as well define our own functions by using the def keyword. So we do that as follows. So let's say we wanted a function that multiplied any number we provided times 2, right? So we started that with def, right? Again, it gets colored by Python, indicating that it's a keyword. So we use def, and then we define any name we want for our function. So let's call it my function. Then we use parentheses, and then we'll have inside parentheses any input, any argument that our function requires. So we would want to require only one thing, which would be the input number that we're going to multiply, and we can call that as we wish. Let's call it x, right? Then we use colon, and in this indented portion of the code, we will write a code that applies whatever we want to happen. So let's say inside here, we want to have a new variable called result, let's say, that is just x times 2. And then we can finalize our function by using the return statement. Again, return gets colored, and saying that we're gonna return, so the function will return the result. Okay, so we run this, and now this is defined within the Python environment. And we will test the function by just calling it as any function. So we do name of the function, the parenthesis, and then we now need to provide some number that we want to multiply. So let's say we want to multiply 10, and then when we run this, we'll see that the result is 20, meaning that the function did exactly what we wanted it to do. So this is it for this video. I hope you enjoyed. And if you want to dig deeper into any of the topics of the notebook, I will make sure to leave, in addition to the notebook, some resources that you can look at. Thank you, and I'll see you in the next video.